Hello everyone, welcome to my channel. In this video, we are going to see how a NAND gate can be built using MOSFETs. First, let's look at the components used in this circuit. We are using two batteries, two pmos transistors, two nmos transistors, one LED, and two switches to control input A and input B. One battery is used to power the circuit, and the other batteries are used to provide the input signals through the switches. The LED acts as the output indicator, so we can easily observe the output of the circuit. Now let's understand the basic structure of the circuit. In this design, we are using two pmos transistors connected in parallel at the top side and two nmos transistors connected in series at the bottom side. This arrangement forms a CMOS NAND gate. The pmos transistors are connected to the positive supply, while the nmos transistors are connected to ground. The output is taken from the point between the pmos network and the nmos network, where the LED is connected. Input A controls one pair of pmos and nmos transistors, and input B controls the other pair of transistors through the two switches. Now let's observe how the circuit behaves for different input conditions. First case, when A equals 0 and B equals 0. In this situation, both pmos transistors turn on and both nmos transistors remain off. Since the pmos network is on, the output is connected to the positive supply and the LED turns on. This means the output is 1. Second case, when A equals 0 and B equals 1. Now the transistor pair controlled by input B changes state. The PMOS connected to B turns off and the corresponding NMOS turns on. However, because the NMOS transistors are connected in series, the path to ground is still incomplete. Therefore, the output stays connected to the positive supply and the LED remains on. The output is still 1. Third case, when A equals 1 and B equals 0. In this case, the transistor pair controlled by input A changes state. The PMOS connected to it turns off and the NMOS connected to it turns on. But again, the NMOS series path is not fully completed, so the output remains high and the LED stays on. The output is 1. Final case, when both inputs are 1. Now both PMOS transistors turn off and both NMOS transistors turn on. Since the NMOS transistors are connected in series, they now create a complete path to ground. Because of this, the output is pulled to ground and the LED turns off. This means the output becomes 0. Now look at the waveforms in the simulation. On the left side, you can see the waveform for input A. In the middle, you can see the waveform for input B. And on the right side, you can see the output waveform. We can clearly observe that when A and B are 0 and 0, the output is 1. When A is 0 and B is 1, the output is 1. When A is 0 and B is 1, the output is 1. When A is 1 and B is 0, the output is also 1. And when both inputs are 1, the output becomes 0. This confirms that the circuit is working as a NAND gate using MOSFETs. Thank you for watching, and don't forget to like, share and subscribe for more electronics explanations.